Out of the 15 chords that they utilized, they found 3 that had absolutely no chromosomal aberration throughout the entire spectrum, the life of that cell, which is like a 90-year-old running a marathon. Number one, if you have to ask one question about the exosome product that's going to come in and that you're going to consider using, what is your documented protein concentration of this product? Show me an ISSCA, show me a Bradford scale, show me something that actually lists this, because protein is number one. So there's a ton of collagen. Obviously we know major components of skin, strengthens bones, blood vessels. Type 1 and 3 collagen make up 90% of the collagen in the body. What's collagen? A protein, right? So we need it. MSC-derived exosomes share the same characteristics as an MSC. We just had a great presentation before, talking about not only what MSCs do, but all the clinical applications associated with it, and you saw it, and it's pretty amazing. They're a non-cellular lipid bilayer membrane that contains proteins. The proteins are not only in the membrane, but they're also the components within the exosome itself. The bilayer membrane proteins become active when the membrane dissolves. When does the membrane dissolve? When it comes out of the cell through exocytosis and gets in that paracrine space, it dissolves and they go out and they do their work. Internal soluble portions of the exosome contain the immunomodulatory cytokines. We talked about that. Unless you modulate the immune system, the body doesn't have a chance. MSC-derived exosomes are significantly different. These are derived from a master cell line of MSCs that have been fully karyotyped to cell senescence. What does that mean? They take the cells from a very specific part of the cell lining and they grow them until they can't grow anymore. All of their cellular divisions until they can't grow. That's basically called passage 10, which you would roughly say would be 70 to 80 years of age in a human life. So they took these, they grew them all the way through senescence till they wouldn't grow them. At every passage, they karyotyped them looking for chromosomal aberrations. 90% of them had chromosomal aberrations. By passage 6, 7, and 8, you start to see for prostate cancer, for colon, for lung, for ovarian, for uterine, all of the chromosomal aberrations you would expect to see in that age group they saw. Out of the 15 chords that they utilized, they found 3 that had absolutely no chromosomal aberration throughout the entire spectrum, the life of that cell, which is like a 90-year-old running a marathon, right? Doesn't happen very often, but they're out there, and they do. What was interesting, in one of the cases, they found trisomy 33 in like the 3rd passage. They contacted the parents, and the parents were tested, and sure enough, they were both carriers of it, and this kid had trisomy 33, and they were able to initiate a therapy long before the kid even showed the symptoms of having it.